So the rule was that let me separate. Maybe not. You know, maybe it's a good way to separate these. Let's just underline this, perhaps, or like this. Yeah, this one, and this one. Okay. So we know that for P3, 3 is divisible by 3, so the valuation will be a 1. P2 is not, so it will be 0, and P3 is a 1. And so the answer for A must be phi is equal to, phi, this is how you write in the test, so phi is equal to then 1 conjunction with 0. A fly entered my nose. Sorry. And we can just simply equate downhill from here. We know from the table x, y, 0, 0, 0, 1, 1, 0, 1, 1. And this case we have, so x conjunction 0, x conjunction y. We have 1 conjunction 0, so 1 conjunction 0 will be what? 0, 0, oh crap, 0, 0, 0, 1. This is just a reminder, so we know that will be 0 in whichever the position that variable is, so the result will be 0. But then we have a disjunction, so we simply reuse this area here, and we do the disjunction, and we say that the disjunction, just as a reminder, requires any of them to be at least 1, so all of them are 1. So we have 0 disjunction 1, which equals 0. 1, which equals 1. Right? Because 0, 1 here equals 1. So that's A done. Let's move on to B. I almost said C. Because I'll be honest with you, this is after, this is before sleeping is when I have time to do this, because I have a school or a college and I have work, and so I'm not very energetic, admittedly, so yeah, I hope you understand. Okay, what is phi equal to this time around? So phi is equal to the negation of P20, so we know that we know that 20 is not a divider of 3, so 21 would be, or sorry, 21 wouldn't, no, only 3 and 1 are, so it's 0, so 0, and then it's negated. Okay, so we can instantly say that this is 1, okay, because it's 0, it's not a divisor of 3, so it's 0, and then it's negated, so it becomes 1. Let me 0 becomes 1. And then we have the implication of the P3, so that's a 1, and negation of 0, which is 1, so implies 1, and then we simply have to solve this. And what is the implication rule set. So the truth table of the implication is that is x. So the rule is that x enables y, otherwise it's 1. Okay. So fast forwarding a bit. Let's see. So let's start with this one. So we know that. So this is implicating this, correct? So this side is implicating this. So this is effectively enabling this. So whichever this amounts to will be enabled. So we can simplify it by saying that 1 implies 1. We can simply look at this area and ignore this one, because we know whichever comes from here will be the resulting set. And continuing, let me get tradition and not bring diffi down. So again, we have a 1 implying 1. So 1 implying 1, the 1 will reside, and the result will be 1. Then we have the next one, which is ABC and C. So we have this one, which will be 0. Then the negation of that one will be 0, because it's supposed to be a 1, correct? Because 3 is a divisor of 3, but it's negated, so it becomes 0. So we effectively have so 0 implying 0 in conjunction with 0 and 1, so 0 and 1, and this. So 0 implies 0, so because it's not 1, the implication will always default to 1. So we have in this area we get the result 1. This term, or the second member, whatever you want to call it, it has no expression. This is 0. The implication default is 1. We have, because of the truth table and the logic that it implies. So, and in the other side we have 0 conjunction 1. So we put the conjunction in the middle and we evaluate this part, and this boils down to both of them have to be 1. According to the truth table, both of them have to be 1 for the output to be 1, otherwise it is 0. In this case it is 0. The same applies to the second term, so the second iteration, so we'll get a 0. And that's the answer to C. Let's try to compress this here so we don't have to change page. So on D, we get, let's see, phi equals, this will be 1, because 1 divides 3, then 1, then 0, and then 1 but negated becomes 0. So we have 1 disjunction 1, close parentheses, conjunction 0 implies 0, and we're omitting this one for brevity. So we have enough space here because we were very we abused the expenditure of C. So let's double mark this, go like this. So from here you go to there, and then go here, and then you go there. Right, so what we get from this is the disjunction. One of them must be 1 for the one of them must be 1 for it to be 1, otherwise it is 0. So that's true. It is 1. And then we have a 0 implying a 0. 0 defaults to a 1. And the conjunction is true. So the result is 1. And that's the result for A, B, C, and D done.